So here, let's see question number 4. It has been derived from the topic calorimetry. The question says something like this. A metal ball has mass 0.1 kg and this metal ball is heated up to a temperature of 500 degrees centigrade. And this hot metal ball is dropped into a vessel of heat capacity. This is not specific heat capacity. Be careful, heat capacity. Of course, the product of mass and specific heat capacity. And it contains 0.5 kg water. The initial temperature of water and vessel is this much. So you need to calculate the percentage increment in the temperature of water, and all the data has been given. Specific heat capacity of water and metal has been given. So essentially we are going to use principle of calorimetry, which says heat lost by one is heat gained by other. And the losing party this time is the metal ball. All right, so let's assume that the final temperature of the mixture is going to be T. And here I get mass is this much. So 0.1 is the mass. Specific heat capacity of the metal has been given as 400. So into 400. And the fall in temperature, that is 500 minus T. So what is it? This is in fact the heat lost by the metal ball. And who is going to gain? Of course, the container with the water. All right. So here that would be equals to, let's see, 0.5 kg of water. So that is going to be 0.5 into 4200 into T minus 30. That's heat gained by the water. But we also have the container. And the container is there, which is given 800 joule per Kelvin is the heat capacity. Well, that's basically the product of mass and specific heat multiplied by T minus of 30. So this basically has given us the heat lost by one party is equal to the heat gained by other party. You calculate it, the temperature value comes very close to 36 degrees centigrade. But the question has demanded us the percentage increment. So here percentage increment can be calculated by 36 minus 30, that's 6, divided by 30 multiplied by 100%. That is the required parameter, which comes 20%. So yes, the correct option for this question is option number 2. Let's move to the next one now. Question number 5. It demands a bit of calculation and a bit trickily formed from the topic force on a moving charge. And it says region between y equals to 0 and y equals to d contains a magnetic field B vector, which is B z cap, directed along z axis. A particle of mass m and charge q enters the region with velocity this much, and d is given the width of the magnetic field. We need to calculate the acceleration of the charged particle at the point of its emergence. So let me try to explain it with the help of a figure. So it's something like this. Say, here's the figure let me make. This is the x-axis, let me take, and here comes the y-axis, and we'll see that this is of width d, so that you can write that this as y equals to 0 and this as y equals to d. All right. So that has been specified here. So now what we'll do is see a particle is entering here, and of course even this is given that the magnetic field is Bj cap. That means the magnetic field is pointing outside and in the k cap direction. And now just try to see. Let's see where is the velocity part. The velocity is this. A particle enters with a velocity vi cap, and the width is of course mv by 2bq. So this is mv divided by 2qb or 2bq, whatsoever you say. And we need to calculate the acceleration when it emerges on the other side. So it's something like this, say. What I can understand is if I say the velocity of entrance is here, that's v, and you just calculate r equals to mv by bq, of course it's in perpendicular, and the radius will be equals to twice of d. In other words, the radius at this point can be said the radius is here. So this is the center, the radius equals to twice of d. And now, this is the center and this distance is of course equals to twice of d. So it's very obvious that the particle would be making a part of a circle here. And let's try to see with the help of a figure. Here is the given situation, say. So this would also be equals to radius, all right? And now, if you slightly see further calculation, this is equal to d and this is equal to 2d. So that's very clear that this angle is going to be 60 degree. So if this angle is going to be 60 degree, right? Now it's very, very obvious that here the velocity eventually will have rotated by an angle 60 degree because that's an angle between the two radii at that given point. So the angle between this radius and this radius is 60 degree, which is so simple. This is 30, 90, and this would be 90, so that doesn't require big effort. So velocity has turned through an angle 60 degree. So this is the point of emergence. And now I need to calculate the acceleration here. So in order to calculate the acceleration, what I will be doing is something like this. I'll be calculating the force, which is Q, and velocity. Let me write it in a resolved way. So that's V cos 60 is in this direction. So that's V by 2 I cap minus root 3 V by 2 j cap. So you get V cos 60, V sin 60, cross the magnetic field. The magnetic field is B of k cap, right? So that's straightforward. Now, once you calculate the force, you divide it by mass, you're going to get the acceleration. And unfortunately, this time, none of the given option is matching with what comes out of the calculation. So here, in the given question with the given option, our take is no option matches with the given calculation. Fair enough. Let's move to the next question now. There we go, question number 6. Another straightforward question, and this time it's derived from rotational motion, wherein the concept related to pure rolling has been there. There's a hollow cylinder and a force has been applied here, and the question says that it rolls without slipping, and we need to calculate the value of alpha in this given situation. So I think things can't go easier than this. Though the friction is acting here, the torque due to friction would be 0 if we take the torque about this point, because that's perfectly allowed at the time of rolling without slipping. So alpha, the angular acceleration, would be F multiplied by 2r divided by the moment of inertia, that's going to be 2m r square, the moment of inertia about this given point. So you put the value of F, put the value of m and r, you're going to get alpha as 16 radian per second square. So for question number 6, option 1 would be the correct one. Time to go for question number 7.